learn about each other in our home environments. But no, I mean this is kind of like that lab, the very first figure one. I just gonna kind of use it to demo it and show. It's like, okay, what are we looking at? And you see, and this thing's kind of cool because it's color coded. I like that. So right now, so I highlighted a blue there, and then if I look at, and you'll see it's really small. And then if we go and set this as our output here, you can even see like our input versus our output. So in this case, the input's blue and the output's green. Yes, we are indeed amplifying in this case. And with this particular amplifier, one of the things to highlight, which is a little difficult to see, but if you see the little ripples there, you notice that the output versus the input, it is 180 degrees out of phase, which this type of amplifier is notorious for. I was going to post a table for you guys showing like the CC and CB, and this is common collectors, and it was close, Justin. You took a different approach, but I would have to run through it, and I wanted to go. That's one of the other things. Justin just asked if his circuit looked right. And Ryan's got internet cutting in, and oh yeah, the storms. I know this is gonna be fun, right? And then of course we got the whole everybody's at home, so the internet's being literally bombarded.
Where do you want us to submit our screenshot at? I know there's different places we could submit it to.
Well, I was of a mind of you could email it to me if you wanted to. It's I mean, we could go ahead. I guess I don't know if is everybody up to snuff at doing like a cut and paste type thing in Blackboard. Blackboard's a pain in the butt with that, I've noticed. I just thought maybe it might be easier if you just if you just submitted the screenshots to me through email, and then what I'll do is I'll make another section up, and it'd be like I don't know, I could call it like lab one photos and then lab one questions kind of thing, and between the two would be your full credit for the lab. That sounds right. Yeah, I'm kind of, in case you haven't noticed, I'm making this up on the fly, right? Things are a little changed with this all.
Well, I tell you what, I didn't realize you could watch the wave there. I appreciate that because that's a lot easier.
Oh yeah, see, that's one of the, yeah, see, like, okay, so if we were looking at this, like if I disconnect here, one way we could do this, right? I can go ahead and cut this and cut this, and now what I got, that's just the straight what we did last the last 8 weeks, right? Now that's just a straight DC bias for this guy. Yeah, no waveform, right? So if we were just to run, yeah, we're not going to get anything. And then it's just straightforward on it. You can go ahead and hook the voltmeter up and just have it be DC response. But the minute we start throwing our AC input in there, and I hope everybody realizes that the output here is a filter, right? So we're gonna start dealing with somewhat. I'm gonna post those up too. It'll just be like this. We're not gonna go really in depth on response of a filter. Just be able to recognize, when you see a low pass filter or a high pass filter, that is what we have hooked up there, right? So in this case, and of course the cap's job is to go and block the DC, like I was saying. So we go and look, all right, there's our before and after the capacitor. See on the orange line there, you're shifted up by quite a margin, right, as our baseline. And then after the capacitor there, you see that it's pretty much right on the 0 volt line here. And so, I mean, that shows you the capacitor is doing its job. It's blocking the DC. The same on the input too. I mean, that's essentially what that 10 microfarad, he's basically blocking the DC from getting back to our input. And then of course, most of these transistor amplifiers, and that's building blocks in what we did in the last 8 weeks. See how you got the flow going on there? Well, that's your DC flow. So the transistor is being still DC biased, right? So basically we're setting up the DC bias, turning this guy on, right? So that way we have our reverse bias and our forward bias happening.
No, just drive it around with it because it's been sitting. It's probably that rust all that's on your rotor.
Say it again? Oh. But you know what I mean? That's what you got going on. And then when we inject our AC in this case, so that's what we're going to kind of look at, right? We're going to look at CCs, common collectors, CBs, you know, common base, and then CEs, like in this case, CE, common emitter. And those are like 3-stage amplifiers or beginning amplifiers that we can look at. And it's without being very complicated, and it builds on what we had going on in the last 8 weeks. But yeah, every one of these guys has got to be DC biased. And then we inject our AC signal, and then you can actually see your amplification occurring in this case. And the way what we would do, just to relate it to our material, is then we would take our, in this case, we would look at it as our voltage, right? So we would say our AV, okay, would be equal to our voltage output divided by our voltage input. And so we can compare that, and we could see, okay, well, how much of a gain do we have going on in this circuit? And that would be our overall transfer function for the circuit, right? We would say, okay, our AV is equal to EO over ES, and then that would equal this ratio here. You know, it could be 10, 100, and so on. And they usually deal with like classes of 10 like that. That's why the importance of recognizing logs and log tables. It's just a real easy way to be able to highlight it in like a graph function. And of course, you know, back in the day, I mean, the logs get somewhat redundant in this day and age just simply because of the whole computer revolution with calculators and everything. But back then they didn't have that. So what was an easy way to represent it on the graph was using the log function. And plus it was a way to deal with cascading large numbers, because you start getting into powers of 10 like that, and it gets humongous. And so then it becomes very difficult to start dealing with. Just like engineering notation makes it easier for us to juggle the numbers, right? We recognize each one's like powers, you know, 10 to the third powers jumping up, boom, 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 instead of having to redundantly rewrite each one over and over again. And that's what logs do basically. And I mean, we're just going to gloss on it just so you recognize when you do see like a log table versus a regular one, that is a log table and what's going on there. And the same with, like in this case, which I kind of thought, you know, it was actually, I didn't even realize that this thing had this. It was an unexpected surprise for me too, but you can, right there, see, you got the Bodie plot. And you can see, yeah, isn't that cool? See how it's got like the little circles here now that I've run that tab. Now each one of those is a plottable point. So if you wanted to see what your response of your circuit was at this point, you can literally highlight that and show it. In this case, see, and just on the fly, I can even switch between my Bodie plots, which is, it's freaking awesome. I'm in love with this thing. No. But there you can see now it's like, okay, so if we were even go and look, and you know, and hopefully part of the labs eventually we can do something like this, and you give me the screenshot, and it'll even relate to your lab and be like, okay, so what is the response of your circuit? And you can see your mid-range here, right, 1 kilohertz, but that's what we're pumping in is a 1 kilohertz sine wave, right? So our mid-range there, and you can see it falls off as we start getting into the low, and you can see it falls off as we start getting into the high frequencies here. But yeah, that would be your, there's your Bodie plot. And then on the side, it even shows you your decibel range. And on this side over here, you even see what your transient deviation is, right? So if we were to say, right, so our input compared to our output, we were 180 degrees out of phase, right? And see how over here, it has negative 180 right at the crossover point, which corresponds right with our waveform. So we could say, okay, at 1 kilohertz, we are 180 degrees out of phase. And of course, you notice it starts to fall off as our frequency gets greater, right? The phase deviation becomes more. And then if we decrease the frequency, the phase deviation starts to become less as it approaches the original signal. So I thought this was actually a really nice little feature with that. And you just rewind it. But yeah, see how you have the two, everyone can see this, right? I'm not just going through. But yeah, you could see how it's run AC or run transient, right? And I'm running my transient. There's my actual, like if I was looking with a no scope, and I just reversed that. But then I hit the run AC, and yeah, I can look at it that way. I mean, I can look at the original signal, of course, your input. It's like, oh, big surprise there. But yeah, you can highlight each one of these points like this, and it's all by color coding. And if I want to get rid of them, I just reverse, hit that highlight like that, and see how it says there. It's hide the waveform again. So now I can get rid of it, blank it off of my circuit. Same with the orange here, and get rid of that and start off from fresh. If I wanted to highlight like other points through the circuit. All right, there we go. And now I have no points selected. And if I were just to hit run, now it's just showing me, oh, here's where your current's flowing. But then if I if I wanted to highlight points, like say I pick this point here, then I hit the little eyeball down there and it's like, oh, look at that. Oh, let's try that again. There we go. We got stuck. But now we can see what my actual output signal is. And you can see it's pretty much, not quite, right? But it's about 4 volts peak to peak signal. It's not perfect on there. I mean, if we wanted that to be, we would have to play with the value of the capacitor, which is also kind of nice with this because you can do it right on the fly instead of having to, monkey around with like a breadboard or something like that. And then, if I want to take it. So yeah, eventually what we might want to do is basically highlight that up, pop it, show your overall Bodie on there, and then take a screen capture of that. And what that does is shows you your overall response to the circuit and that kind of thing. Is that kind of clear for everybody? I hope that makes sense.
Yeah, that makes sense, Tom. I can do that.
Okay. Well, I mean, and there's like I say, hidden features and things. You guys are just being fresh and just starting out with that. But yeah, you can definitely highlight just about everything on here. Like I say, when you just hit run, it's just showing you the possible points where there's something occurring. And in this case, you can see these little, I don't know, those are strange ass symbols to me. But anyway, you can see here these little sinusoidal bouncies, right? It's showing you, okay, here's waveform. And there's even one, I mean, if you sort of look close, you can see that there's something going on here as well. It's just compared to the output, it's really small. So we can even look, like if we were to look at that point, right? Yep. Yes, indeed, we have a sinusoidal, but if you look at the range, it's in the millivolts here. And it's usually what they have for these type of amplifiers. And the reason being, a lot of these are used in media and communications. So if you were to broadcast, you want to be able to broadcast a small signal just because of the power considerations and such, right? So what would happen is your circuit would be going through, and you'd be broadcasting and receiving some type of radio or TV signal in, and then on your other end, excuse me, you would have this guy sitting there taking that small level signal and amplifying it for you to use, within radio. And that's how basically, I mean, it's a lot more complicated than this, of course, but with that, that's kind of how the whole radio and TV works for us. Oh, hold on here. What do we got? So we got a request to do a start to finish. Well, we can do that. I can model. All right, let's do. Start with a clean slate. And I mean, we can look at all kinds of crazy crap. If I were just to look at I don't know. Look at what I like to do is what I'll do is I'll set it up. I'll decide what kind of components I'm going to need, right? Pop them all down there. I might need a ground. Too far. You've gone too far, my friend. Oh, not two. One. Into the trash. But yeah, we can go ahead and set him up. Let's give him, I don't know. We'll get my beta at 200. I don't want him that way either. No. Yeah, my mouse kind of sucks, so bear with me. It's getting old, like me. If you're just even looking like a basic circuit, right? Oh, good lord.
You gonna bring me one?
Yeah, get your stuff in there. You got your power supply, right? I don't like it the way it's oriented that way. Now remember these DCs. Now see how it's got two nodes on the end, and it even shows you a plus and a minus. You know, and don't be afraid to flip them. Well, in this case, I want a positive.
Stuff coming. Oh, thank you.
Join them up.
Huh? Yeah.
Start muting everybody. Right, because your power supply, you know, one side's a black lead, one side's the red lead. And this would be a very simple, like what we had way in the beginning. You know, just a DC biased. If we go now, it'd be unbalanced if I leave it as 1K and 1K. So let's give it a little something to chew on here. You know, decide what your, and you can even do this before you even set up the circuit, you know, layout, just like you do with lab. This is your breadboard, lay all your parts out that are for that lab, right? You can even go ahead and set your values ahead of time or after. It's your call. And then we go, we'll go with like a 10-to-1 rate. Yeah, we'll make him 10, like so. And then this is just DC, so of course we really don't expect to see much. Does my circuit work? Well, it looks like it. I mean, in this case, there's not much to really see. It's all DC, but if we even go and pull through, like if we wanted to measure stuff, right, we can even plug in a volt. Oop, oh, God. All right. Let's check. I mean, we know our VB here should be about 0.7. So in this case, it's 0.658, you know, 658 millivolts. So we know that that transistor is pretty much balanced with this. We could probably tweak it a little bit and make it better, right? And this, of course, this circuit's beta dependent with this configuration because with this, we're cranking out pure current source. There is no balance of what we've seen. So we know with this emitter type that pretty much this circuit sucks, right? But yeah, you could take your voltmeter back out. You can even leave it on the side if you want. And then, I mean, it's got all, you know, it's got the ammeter and it's got an ohm meter with it. You can even set up like these guys, right, where you got this. Now this would be good for like doing modeling. So you've seen like the pi models or the T models they've had for setting up a transistor, right? We could use this for that, and then actually have our circuit branch off and basically pretend on our transistor. It's like, okay, what would our internal resistance be and that kind of thing. So if we were setting up a pi model, we could totally use these sources like this, which is kind of nice. And yeah, there's different features with it. I mean, even to the point, we could put a potentiometer in there, right? Kind of nice. Got single pull, single throw. You got a single pull, double throw type switches, which is kind of nice. I don't think we're going to use those push buttons. But I mean, there's a lot of stuff with this, even to the point of like digital ends. You know, you got JK flip flops, you got your latches. There's a D and a T, right? And you got your RS flip flops. In this case, got decoders. You even got a 7-segment display, so that kind of thing. I don't know if Bob is planning on using that, but there's all your gate functions, even if you wanted to, and logic. So pretty much from this end on, we're not going to be using that. We're going to be mostly sticking this way. We got our standard diodes in this case. There's an LED. You got your regular diode. You got a Zener. So later on we will be using those. We'll be able to throw those in there as well. But yeah, I mean you can play with these in different ways. the versatility is just insane, right? Like so, run that. I'll go a little more balance. You see, now we're at a 739 millivolts on our base there, which makes it a little more stability. And we can even, if we wanted to, go ahead and it's like, oh, well, I want to see what it can do as far as being an amplifier. And it's like, oh, fine, we'll be an amplifier. So in this case, oops. Yeah, it doesn't like when you cascade. No, and with this, I mean, you know that's not going to run, right? What am I missing? It's like, well, oh. So you could do that two ways too if you wanted to. You could attach it here. You can bring it around and attach it to ground like that if you wanted to. You know, you don't have to use that way. It's really whatever your personal preference is. I can bring my own ground in here, you know, and just recognize, you know, ground is ground, right? Whether or not we have it hooked up like that, like I did previous. And we can go through and oh. Spin them. I don't know. I'm like I say, would it help? Oh, don't want to do that. Get out. Would it help if I do like I have no problem with it. I can do a model and basically even attach that circuit like that in there for each lab under the folder if you want. We're not all Facebook friends, so we can't share. See how it's got that Facebook feature, but I do have a unique ID on here, and what I can do is I can save each circuit to the point where if you did a search on it, right, there's my lab 1 demo that I did and it's saved. But if you did a search on like my particular username with that name, I guess I could get a little more complicated and match up the lab name, and then you could search it. But see, the problem I have with that is then you're not setting the circuit up on your own. You're really just, you know, porting in my circuit and then running it. And then, I mean, you still have to answer the questions, but I would rather just do like say a screenshot of this, if you will, and then and have you go ahead and set up your own labs if that makes more sense. So yeah, this thing's weak. I don't have any of my values set, so what we're gonna see is pretty awful. Yeah, my amplifier has a major amount of distortion to it. And this is a good example of distortion, right? So if we look at what is happening to the signal, well, essentially my maximum power transfer theorem is not balanced. And now we go to a straight sawtooth. Look at that. So the input compared to the output, yeah, this thing is not balanced at all. I obviously didn't do my math. We're gonna look at my Bode plot. This thing, yeah, this is an awful circuit. No, but it's kind of neat. I mean, you could see, right? So it'll even show you. We can even go through and not look at that anymore, and look at this instead and see. It's like, oh yeah, what's your overall response there? Yeah, it's about what I thought. It's crap. And my overall Bode response, yeah, it's nothing. So in a circuit like that, yeah, the problem with it being there would be way too much feedback, reflections, if you will, and it literally would kill my output signal to the point where this circuit would be non-usable. Yeah, that's pretty much how I do it. You just go ahead and it's like, I'm going to try to make sure that the labs are more comprehensive. And, and one point on this too, When you see VCC, VEE, VBB, those are referencing DC sources. Okay. Usually from the way I'm used to seeing it, you would see like a capital B in this case. And a capital B would mean that that it's referencing a DC source. And then what you would see would be for like an AC would be a lowercase, like B in this case, but it would be almost italicized, like a handwriting style. And if you see something like that, then that would mean that it's an AC source, if that makes any sense. So you could see like a BEE, but what it would all be would be like lowercase.
You guys hear me? I can't hear anything.
What was that? I'm getting a lot of feedback. No. but yeah, that's kind of, does that help? I mean, that's kind of a start to finish circuit, more or less. And we could do this all day long with different circuits. That's why I was asking everybody to go through and play with this. You could even do, go ahead and even set up simple circuits. We could set up filters if you wanted to. If you were to look and basic filter. Oh my God. Yeah, my mouse is awful. If I don't hit it just right, it seems to not hold things for me. I don't know why.
That's the thing with like so I have a Chromebook, so I like the actual app on mine. And sometimes it's like you barely have to even like.
Yeah, where you're not really grabbing it. Yeah. See, it's such a pain in the butt. But yeah. Will this circuit work? Oh, see, even highlights and tells me, all right, dummy, you forgot to attach your ground. So we can attach it there if you like, or stick to our normal convention. Put it back over here. Now, does your circuit run? Yes, it does. See, now I got points. So we can look at our different points, show our wave, our waveform output. We can even compare input to output. And I didn't change any of the values on this, but this is a simple filter. And we could see that, yep, RC, we definitely got some phase lag going on from input to output. So the input signal is the green one, the output one's the blue one. We can come up with better circuit balance too for it. This is the kind of the cool thing on this thing. I just love this so much. You can even change it on the fly, right? Like, oh, what does that do? Well, let's find out. Oh, you know what I mean? And that's just like basic playing with the circuit. Just think of this thing, like I say, just think of it as a breadboard. Here's all your components, drag and drop them. Like I say, match them up, make sure you're doing, what you need to do as far as the labs are concerned. Recognize your basic symbols. And you can even, hold on here, if I can do this. Yeah, you can go in your profile and even change, like if I go to these types of symbols, it does change them somewhat. Now I just, instead of a squiggly line for resistor, we just have the resistor block, that kind of thing. If it helps you see it that way easier, we can do that. Me, I'm kind of old school, so I do not like that. There we go. But yeah, that's pretty much it. They do have a lot of, the other thing too is they have a lot of like example labs out there. I noticed some of them were kind of easy with a lot going on. Look at this guy's circuit, right? I'm not even sure what the heck this is. It just looked complicated. But yeah, I mean, you can really get a good complex circuit going on here, which is kind of nice. And I noticed that a lot of universities have been using this. I know it's already been tested out. I know Stanford was one of them, and there's a few other universities that use this thing. So I figured, well, if their math isn't right or something like that, these other places wouldn't be using them. So, but I do like it. I do like it. Anyway, do you guys have any questions on the homework for chapter 34? Was 34 pretty straightforward, or I mean, we can go over. I got other stuff we can look at. I might. I haven't decided yet. I might jump around a little bit. I don't. Again, the way Frenzo has this set up, we're going to go right from 34 amplifier fundamentals. We're going to jump right into op amps, and I am not sure I like that. So I might have us jump from 34. We might go to chapter 37 and continue on playing with transistor models first. Because I find it easier just to go over, since we understand transistors and how they work. And the way I'd like to do it is have us step up from transistors, like the common forms, right? The common collector, the common base, voltage divider, and common emitter amplifiers, and then work up to a Darlington pairs. And then once we start recognizing and we're able to deal with the Darlington pairs, I'd like to do that kind of this week. And then we can look at op amps next week. Because Darlington pair was like the original, and in fact, that's one of the things I'll show you is from the Darlington pair is how they essentially created the first operational amplifiers. So from Darlington pairs, once we get through that and we recognize it, then we can jump back and do chapters 35 and 36, and that would complete my amplifier understanding. Because essentially we're doing, I mean, really when you get down to it, there's really two basic styles of amplifier, if you will. And either A, you're going through like in like media, right? Radio, TV, and that kind of thing. Or you're doing power amplification. And there's different ways to deal with that. I mean, if anybody was a musician, you know, like you had your guitar hooked up to an amplifier, right? That would be a good example of power amplification. And it's a difference. I mean, amplifiers are amplifiers, but it's a different approach, if you will. So we could do, because then you go, I mean, essentially you're still dealing with signal amplification. It's just the setup of it. And yeah, as we go further along, these circuits will start to get more complicated because you've got a lot more stuff happening where we just don't have a simple input versus you know, an amplified output, if you will. I mean, you always have an amplified output. It's just what we're doing to the circuit as we get there. Excuse me. But that's kind of how I wanted us to approach it, and I think that'd be a better way. If I jumped with the Frenzo book, we'd be going literally from this chapter and jumping right into the op amps, and I would rather not do that. I would rather, we're going to skip these next two chapters, continue on with the different styles of transistor amplifiers, and then we'll go on and we'll deal with the operational amplifier after that. And then what we can do is then we can play with some of the complex stuff a little later on too. We'll show you I did notice he has a chapter where we do play with the 555 timer, not from a digital aspect, but more from an oscillation amplifier type aspect, which the 555 timer can do as well. So I guess in a way it would complement the digital class, because Bob showed you how it can be used for making a clock. And yeah, the oscillator is similar to that, but we'll be looking at it more from an analog approach instead of a digital approach, which I think will kind of round it out. And then we could also look at thyristors, and that would kind of complete it. And and we have several labs, and hopefully if we're able to get through the homeworks and the quizzes and stuff, we'll be able to play around more with labs. And I think that, I don't know, we'll have to see how it goes, and hopefully by that point, everybody's pretty proficient with this every circuit simulator, and we don't have as much trouble with it as we did. And I know, it was it's been a heck of a thing. And the same for me. Like even doing this, I've never hosted video meetings in my entire life. You know, my experience level is about like this, a big fat zero. But I got the full license now, so we're not cut off after 40 minutes in this case, which will be nice. Yeah, that was fun, right? Just boop, your meeting's over. I was like, awesome. So now we got the full license now. Oh, excuse me. So yeah, I was gonna go through and I mean, good for you, right? Every quiz is a take-home quiz, so that'll be nice. We'll do the chapter 34. I'll post up a chapter 34 take-home quiz. It'll be based on the homework, right? Not as many questions, of course. And then we'll, like I said, I think we'll skip 35 and 36 for now. We'll go on to 37, possibly 38, and do that. And then we'll jump back and do op amps. I think that'll be more balanced for us. I just feel it's a better approach, just getting through the whole Darlington pair, working out of the Class A and Class B amplifiers. And they have such a range. I mean, you go Class A, B, C, D, E, F, all the way down the line if we wanted to. But Class A and Class B are the most commonly used ones out there for like media communications and stuff, you know, the radio. Pretty much after we get through this, you'd almost be able to even understand how a radio goes through. I mean, if we get through far enough, we could even do tuners and stuff like that, where you could even like build your own radio at home. Something simple like they used to do back in the day, where you can build your own AM radio, which would be kind of cool with the times coming up, right? Survivalist 101, build your own AM radio. No, but we would be able to do that, which is kind of neat. And that's essentially, I mean, what we're going through with amplifiers, right? So, but that's how I wanted to do it. I don't know. I will probably inject some of the Malvino stuff in there for reading and whatnot. I mean, he does have a couple of things in there on amplifiers. Oh, where are we at?
Could you post on Blackboard like what chapter homework goes with what corresponding book? Because I know like sometimes like on the last homework, like the Frenzel book worked. That kind of corresponded with the homework.
Yeah, kind of like show which Malvino ones are going with which ones, kind of thing. You mean? Or oh, absolutely, I'll do that. Yeah.
Awesome.
Look at it this way: I have nothing but time on my hands right now, so.
Hey, Nicholas asked a good question. Wanted to know if the class was getting pushed back a week due to the extended spring break.
You know, I have to check on that. Yeah, because the way they had it originally ending, right, we're like a week overlap, right? Because I have to find out about that too. When I was posting up my days, and I'm like, oh, wait a minute, this doesn't work out right. So I believe they are. Oh, here we go. Did finals get pushed back a week due to extended spring break? Yeah, I think, yeah, because we have a week overlap. I gotta check. I'll check them. I have to check because I know the original calendar, yeah, it didn't match up like this. Yeah, so now we're going to have, I have to check. There's not going to be as much, downtime in between the end of spring and the beginning of summer terms as far as that goes. And then we don't even know at this point, are we going to have the summer term going to be on campus, or is it going to be off campus, or how they're going to do that? Because I have two summer classes I'm teaching. If any of you guys are signing up for residential, it'll be me. But no. But yeah, that's how.
Say I'm in industrial for next semester, and I don't want to do that online. That sounds like a nightmare. The
150.
Yeah, the 4-week super crunch.
You know, I was looking at, because they do have some interesting. I don't know if Zach's going to use them but yeah, you definitely. And the same with my residential class. That's more of a hands-on oriented thing, right?
Yeah.
Not getting hands-on and actually wiring things up. That's a nightmare by itself. I know there's a couple of simulators out there for like controls and stuff like that, which is kind of close, but yeah, it's not the same thing. because there's I'm trying to remember. I think it's called the constructor or something like that, and you do deal with like motor controls, setting up ladder diagrams and stuff like that. But yeah, how I mean, you're not
Not the
wiring
same.
stuff up. It's just yeah, I agree. So that's why, yeah, and I still haven't found out yet, but that's why they were looking more into a pass fail grade for this online thing as versus the, traditional A, B, C, D, F kind of thing. So I believe you either get the pass, you would get would be in a way the best because then it would have the best impact for your GPA, right? Being the highest amount of points available.
Um,
Huh?
my math teacher told me that the pass fail wouldn't affect your GPA.
It wouldn't affect it? Is that how
That's what
they
he
look
was.
at it?
That's what he was saying. Yeah.
Okay. That makes sense too then. Okay. See, they weren't real explicit. Well, because they still haven't found out for sure. I know they're in negotiations with the accreditation people, from the government and whatnot. So yeah, they still have to work that out because they also, financial aid gets involved and how does that all work? Oh my God.
Yeah.
But yeah, I'm I'm way down on that totem pole, so I get information basically as it's meted out. I probably won't know anything for sure until closer to the end, which will be wonderful. But but at least for this class, I mean, we're still able to do circuit setups and stuff like that. So for the electronics point of view, this will still work out. But yeah, for as far as like those other ones, really, I mean, even 150, the best you're going to be able to do is like go through all the chapter homeworks and essentially use software to do ladder diagram layouts, drawing schematics, if you will. But yeah, you won't be hooking up motor starters and timers and stuff like that.
Yeah. I'm just not looking forward to 6 hours online camera thing because how reliable this is.
Oh, I agree with you. Well, this hasn't been too bad as far as
So far,
yeah. Well, you got to figure though the internet's pretty well. I mean, this is like the highlight of the day at this point, right? We're getting close to 2 in the afternoon. So this is when I know the internet is at its busiest. But yeah, no, we'll have to, like I say, it's all play it by ear. I know a lot of companies and even portions of the government at this point are really looking at getting things back on track. But how do you measure that? I don't know. Not my call. That's all politics. It's crazy out there. They did have that one senator though that did come out and his statement was that people, death is part of life, and I was like, wow, you're not getting voted back in again, are you? No. Oh, good Lord. Oh, let me get my thing set up. Well, I mean, do you guys want to continue on, or is this, you need a breather? Is this too much? I mean, we can even look at amplifiers a little bit if you like.
Take a 15-minute bathroom break.
All right, yeah, we can take a little break for Q&A or whatnot. I don't mind. So yeah, give it a, well, probably. All right, I'm gonna stop recording.